Hello and welcome to Technology Update. In this episode, we'll be exploring the revolution going on in atomic energy. The need for increasing amounts of power is being tempered by fears of nuclear proliferation and safety concerns. Over the next 25 minutes, we'll be asking just how peaceful is the peaceful atom? As developing nations get richer and more populous, global demand for energy is on the rise. According to estimates, world electricity consumption is set to grow by more than 75% by 2035. With many countries worried about the harmful effect fossil fuels have on the climate, there's a big push to move away from coal, gas, and oil for power generation.
The world's consumption of electricity is growing, and so is production. The figure has been basically stable for many years. Sometimes it can vary for quite a number of reasons. But generally, one should know that global electricity consumption is growing at an annual rate of about 3 to 5%. This is a trend, evolution, progress, and development of our civilization in general.
Прогресс, развитие вообще нашей цивилизации.
And atomic energy is going to have to play a big part in meeting our increasing needs. There are currently around 50 new reactors under construction in the world. Over the next 20 years, electricity production from nuclear power is projected to more than double. At present, there's at least 30 countries operating more than 400 nuclear power plants worldwide. The United States has by far the largest number of facilities. While they may be the leader in nominal terms, nuclear energy certainly plays the biggest role in France, where it accounts for about 75% of all electricity generation. Earlier this year, Iran fired up its long-delayed Bushehr reactor and connected it to the nation's power grid. While Western nations are suspicious of their intentions, officials in Tehran argue that they're only interested in the peaceful benefits of nuclear technology. But when we speak about nuclear reactors, it's not the only concern.
It's still chance discharge meltdown of the core zone and the scenario like in Fukushima.
The disaster in Japan has reignited some fears about the dangers associated with atomic energy. Even though the March 2011 incident was the result of a unique sequence of events, many anti-nuclear activists think it's just a matter of time before the next disaster strikes.
The scenario how it could happen could be absolutely different. You do not need tsunami or earthquake for it. We have terrorist attack, we have human being errors, mistakes, culture of labor.
That threat has driven many concerned citizens out onto the streets and protests, hundreds of thousands in Germany alone. The nation's parliament passed legislation designed to eventually make the country nuclear-free. However, this renewed concern was not isolated to just Germany. Similar rallies took place in Korea, Taiwan, and France as well. Despite the ongoing worries about the viability of nuclear power, we're likely going to continue to rely on atomic energy for at least a part of our needs. Russian scientists and engineers are drawing on decades of experience to make the next generation of reactors as safe as possible. But in order to understand the future, we have to look to the past, which takes us to the Beloyarsk power station in Zarechny, some 1,000 miles east of Moscow. The plant began life as one of the most advanced nuclear power stations in the world. Construction on what was to become the globe's first graphite-moderated reactor got underway in 1958. And a few years later, a second, more powerful reactor was built. Together, the two generated more than 250 megawatts of electricity, or enough to provide a city of 1 million people with lighting and other modern amenities. Looking at present nuclear capacity, the vast majority of the world's atomic power comes from pressurized water reactors. There are about 250 of this kind in operation across the globe. These old-style reactors are most prevalent in France, as well as in the US and Russia. Next, we have boiling water reactors. In these, the coolant isn't as highly pressurized, which allows it to boil, hence its name. About half of Japan's nuclear plants are of this design. Gas-cooled reactors, as the name suggests, utilize gas instead of water, which often allows these to transfer much more heat to the generator, resulting in greater efficiency. Then there are light water graphite moderated reactors, which are called high-power channel reactors in the former Soviet Union. Lastly, pressurized heavy water reactors are most common in Canada. Here at Beloyarsk, they've ditched the dated designs of the past and are pushing ahead with fast breeder reactors. While the technology isn't exactly brand new, it's still thought to be the future of nuclear energy production. This is what's called Beloyarsk 3, or the third and only currently operating reactor on the site. The BN600 is housed here, which has been churning out electricity and thermal heat for the region's residents since 1980.
The BN600 power unit has been operating for over 30 years. Its operation license has been extended till 2020. The area has good prospects in terms of producing renewable nuclear fuel.
In fast neutron reactors like the BN600, energy is produced in the core when fast neutrons are absorbed by a fissile isotope like uranium-235. A fast neutron travels at a very high speed, around 14 million meters per second. After an isotope captures one of these neutrons, it forms a highly unstable variation. That then quickly turns into energy in the form of heat and more neutrons. Criticality is reached when there's enough fissile isotopes to sustain a chain reaction. Unlike in traditional thermal reactors, there's no moderator involved, which allows the free neutrons to whiz around at speeds fast enough to keep the reaction going. Despite its relatively old age, it's still on the cutting edge of nuclear technology. In fact, sodium-cooled fast neutron reactors like the BN600 have been designated by the US Department of Energy as the next generation of nuclear power. If the core is surrounded by a fertile blanket of uranium-238, it can create new nuclear fuel from spent, otherwise unusable material. When operating in the so-called breeder mode, fast reactors like the BN600 can create more fuel than they actually burn. That can then be used at other nuclear power plants as fuel.
Many innovative solutions were implemented in the design of this power unit. This reactor is based on the principles of natural self-protection. The BN600 power unit's active zone has a very even power density field. The pressure inside the vessel is very low, which ensures a reduced load on the reactor vessel. Sodium, which is used as the coolant, is not very corrosive in nature, which has a positive impact on construction materials. Also, a triple circuit cooling system has been applied, as well as an intermediate sodium circuit, in which the sodium is no longer radioactive. Therefore, the steam that flows into the turbo generators is already clean and non-radioactive.
Thanks to that technology, the reactor is able to churn out 600 megawatts of electricity. From this halt, steam is turned into power and delivered to the region's grid. To get a longer lease on life, the plant's generators were modernized and a host of other changes were made to make it even safer.
According to the design, there was initially no reserve control point for Reactor 3, but we had to upgrade it in order to extend its operation term. Therefore, a reserve control point was built. It includes the key technological features required for supervising the reactor's condition in the case of an emergency failure, because a reserve control board is necessary for such emergencies.
But that reserve point is only necessary if something were to go wrong with this main control room. From here, all the plant's vitals are constantly monitored. While there have been a handful of incidents with the BN600 reactor, all of them were minor and didn't require so designated emergency action. However, officials are now confident that all the kinks have been worked out. But all the plant's new safety features and technology haven't come cheap.
Generally, fast neutron reactors are presently somewhat more expensive. But with time, as prices for nuclear fuel keep rising as a result of diminishing resources, fast reactors will be in greater demand. This is a general trend all over the world, recognized by France, India, China, and even the US has resumed its work in this field.
As the price for uranium goes up, Russia will be in a better position than most. That's because in addition to the already operating BN600, in the coming years there'll be the next generation BN800.
The active construction of the unit began in 2006. That's when we finished building the pit for the main vessel and constructed a powerful 3-meter thick monolithic slab to go under the reactor and a 1-meter thick block for the turbine hall.
Work on the fourth reactor at Beloyarsk actually started back in 1983, but construction was halted in 1986 following the disaster at Chernobyl. Since that time, however, the authorities have realized the increasing need for clean, efficient energy. For that reason, back in 2006, the Russian government added the BN-800 to a federal program aimed at developing the country's nuclear power capacity. Construction is well advanced on Beloyarsk 4, which will house the first BN-800 reactor from the Afrikantov Design Bureau. But that's not the only thing planned at the site. What you see in red is what's already been built. What's green is still under construction. As you can imagine, the main building is the one that'll house the BN-800 reactor. But of nearly equal importance is the waste treatment facility. Here, highly radioactive material will be transformed into a new fuel. And in a few years' time, construction should also get going on two other structures, the BN-1200 reactor and the lead-cooled Brest OD-300. A number of innovative solutions have been adopted in the BN-800 design to enhance nuclear and radiation safety. Crucially, the new reactor relies on a low operating pressure, the natural high thermal capacity of sodium, as well as a dual-layer protective vessel to ensure problem-free operation. Just like the BN-600, the new reactor will be able to work in breeder mode, which means it can create new fuel for other power plants. However, based on an agreement with the United States, the reactor at Beloyarsk can be used to burn weapons-grade plutonium, which ought to help non-proliferation efforts.
This reactor has all the best elements that were used in the BN-600, but with certain modifications that arose during the operation of the reactor. As you may know, the BN-600 has been in operation for more than 30 years, so of course it was invaluable to have both the manufacturing plant and the design bureau that took part in producing and designing the BN-600 apply their vast experience this time.
While the BN-600 laid the groundwork for the current reactor under construction in Beloyarsk, the experience being gained from the BN-800 is already being put to use here in Obninsk, where you can find the Institute for Physics and Power Engineering. It's been a leading scientific center since the days of the Soviet Union. They're currently working on another fast neutron reactor, the BN-1200. As more and more of these are developed, they'll play an increasing role in the country's nuclear industry.
A small series of the BN-1200 power units could be used to develop the fuel infrastructure necessary for fast reactor technology, which would allow us to start introducing fast reactors on an intensive basis in the nuclear power industry by the 2030s.
Despite its increased production capacity, up to 1,200 megawatts, the reactor's core is expected to be significantly smaller in size than its predecessors. But innovation here in Obninsk doesn't stop with the BN series. Scientists are also researching other types of liquid metal coolants. The most promising appears to be another high-powered fast neutron reactor, cooled by lead bismuth. High-capacity fast neutron reactors are not the only way forward for Russia's nuclear industry. A team of engineers is working on a new design that takes a totally different approach to atomic energy. Here in Nizhny Novgorod, centuries of culture combines with technological innovation at the workhorse of the country's nuclear industry, where the Afrikantov Design Bureau is developing the very latest high-temp gas-cooled power plant.
In 1995, there was a renewed interest in this technology. The Russian Ministry of Atomic Energy signed an international agreement with private companies, including General Atomics from the United States, Framatome and Fuji Electric from Japan. A joint project called GT-MHR was launched as part of a public-private partnership.
Now, the project under design is a helium turbine reactor. In some ways, it acts like a normal nuclear power station, but greatly improves both safety and efficiency. Heat is transferred to the electricity generator by high-pressure helium gas rather than through pipes containing water. It only has one heat transfer mechanism instead of two or more. That means the generator will be much more effective than traditional setups. Simply put, loads of complex hardware aren't needed. That offers not only benefits in terms of efficiency, but should make the helium reactor safer as well. Without any water involved in the heat transfer, there's no risk of a steam explosion.
Because of its huge mass, the presence of temperature-resistant materials, and the absence of metallic materials, the active zone can never melt. This property is ensured by the type of materials used and by special configuration of the active zone.
Here, engineers are hard at work to put the project's lofty goals into practice. In addition to a safer reactor, a number of innovations should reduce the risk of nuclear proliferation. For one thing, the special design of its fuel will ensure that weapons-grade plutonium is destroyed in the fission process. In 2010, the gas turbine modular helium reactor was included in an international nuclear disposition strategy. Together with other nuclear institutes around Russia, the Africanta Design Bureau is in the process of testing many of the newly developed technologies. In the end, this reactor could produce nearly 300 megawatts of electricity. But powering your TV is only one of the ways that it could benefit you.
The question is, should the nuclear energy sector focus on this niche in the immense market of non-electric applications of atomic power? That's exactly what we've been doing, researching and developing projects. And we're really seeing the implementation of nuclear energy in the non-electric sphere.
One way that this new reactor type could find its place in the market concerns how we get from point A to point B. Over a quarter of all energy-related carbon emissions come from transport, a figure that the IEA predicts to double in 20 years' time. And with international arrangements like the Kyoto Protocol, many nations are counting carbon emissions like I count calories. The high temperature inside the reactor will enable it to produce hydrocarbons such as hydrogen from thermochemical and electrochemical decomposition of H2O. That essentially means that we can get a new fuel source to power our cars just from water.
As the world's population continues to grow, people are moving further and further afield to live, work, and get at precious natural resources. A new Russian design will soon bring the benefits of nuclear energy to the most remote of locations.
Now the technology making that possible owes everything to the Lenin. No, not that Lenin, the nuclear-powered icebreaker. In 1959, it was the first of the country's civil atomic fleet. Nearly 20 years later came the Arctica, which was used as the base model for most that hit the water after it. Since then, Russia's been tearing through the Arctic's thick ice thanks to extra strong hulls and the additional push provided by nuclear-powered engines. Since their debut, Russia has churned out increasingly sophisticated models like the Tamir and Yamal. The most recent addition to the nuclear-powered civil fleet is a ship whose name could be translated as the 50th anniversary of victory. This behemoth is the final Arctica-class icebreaker. The vessel has no problems dealing with whatever the freezing cold water up north throws at it. With its atomic-driven propeller and innovative spoon-shaped bow, it can cut through ice up to nearly 10 feet thick. It boasts a top cruising speed of over 21 knots, and now that it's seaborne, it can be used to clear the way for cargo ships navigating the Northern Passage. However, it's also functioned as a tourist vessel, leading trips up to the North Pole. Its hull has been outfitted with additional cabins, as well as a swimming pool, gym, library, and restaurant. While ships like this are impressive in their own right, what's really exceptional is what's being developed on the basis of their nuclear technology.
Since the beginning of this century, our industry has been actively working on an innovative and absolutely unique project, a special-purpose nuclear station, unique in every sense of the word, that meets all safety requirements of the Russian Technical Supervisory Authority, the Russian Maritime Register of Shipping, and international supervising organizations, including the International Atomic Energy Agency. Again, here I'm talking about the floating nuclear power plant.
Russia is using the core technology from nuclear-powered subs and icebreakers to build mobile power stations. These could in theory be docked anywhere along the coast where they can offer a stable supply of both electricity and heat to nearby populations. In many cases, they'll be more economical where coal and oil supplies remain costly and difficult. Each floating plant will be far less expensive than traditional nuclear stations and can produce enough energy to power a city of 200,000.
The administrations and governments of countries that are presently experiencing a shortage of energy are greatly interested in this project. Primarily, these are island states, such as in the Southeast Asian region, as well as a number of developing states, which don't have the opportunity to use nuclear technologies, but are very much interested in them.
The first of these floating energy outposts is the Academic Lomonosov. Construction on its 21,500-ton hull started back in 2007. The massive vessel was outfitted with two modified KLT-40S reactors originally designed for nuclear ships and submarines. The Academic Lomonosov was launched into the waters off of St. Petersburg in 2010 and is slated to come online sometime next year in Vilyuchinsk, a city on Russia's Kamchatka Peninsula. Quite fittingly, it'll help provide energy to the atomic submarine base out in the Far East. In addition to supplying power to isolated communities, officials expect there to be great demand for ships like this, which could also power offshore oil rigs.
The global professional community recognizes Russia's leadership in this sphere and also a certain concern from the viewpoint of competitive advantage in this area of work.
Given the country's edge in atomic shipbuilding, there's likely going to be a lot more work to be done at this production facility at the Baltijski shipyard. The floating power plants will be constructed here, fit with the reactors, and then shipped off to their final destinations, wherever that may be. But Rosenergoatom, which is responsible for the project, will only be leasing the ships to other nations. That means that if and when the time comes to pull up anchor, the power plant and any potentially dangerous material will be towed back to Russia. Since the floating power plants are based on tried and true technology and utilize existing production facilities, there's seemingly nothing standing in the way of turning the idea into a money-making cash cow. While the massive barge may get all the glory in press visits and photos, the whole thing is only as powerful as the reactor at the heart of it.
The KLT-40S is a reactor unit that's used as the energy source for the floating nuclear power station that's being built in St. Petersburg right now. It's based on the reactor using icebreakers of the Russian fleet. However, it's been upgraded to ensure a higher level of safety.
On board Russia's floating nuclear barges will be two of these bad boys. Each KLT-40S is designed to pump out around 35 megawatts of electricity and produce about 240 tons of steam per hour. It's a pressurized water reactor fueled by enriched uranium. According to the designers, the nuclear fuel will be enriched up to about 15 to 18%. Some argue that having such radioactive material just bobbing in the waves off the coast could make the ships both a safety and proliferation risk. Furthermore, they could be a potential terrorist target. Officials, however, claim that they're even safer than land-based reactors. The modified stations were designed and built in Nizhny Novgorod by the Afrikantov Design Bureau, the same company responsible for work on some of the others highlighted earlier in the program. In this design room, the skilled Russian engineers have turned their watchful eyes and super powerful computers to maximizing efficiency and safety of Russia's floating nuclear fleet. Using the latest technology, these engineers are able to map out bit by bit just what the finished product will look like, as well as run models to test how they'll perform under specified conditions. With the KLT-40S already taken care of, they've now focused their attention to the next generation reactor for floating power stations.
We didn't stop at that project. We've developed and almost finalized a project for a new floating power station unit. This will be a new integral reactor. Presently, there's nothing like it in the world just yet. This project is being developed with the help of these supercomputer technologies.
In addition to providing a new source of energy, these nuclear reactors can help solve another global problem. The heat and steam produced can be used to desalinate water, which can turn a dry, thirsty city into a desert oasis.
It's indisputable that more and more energy will be needed to meet the world's growing demands. Now, of course, there are risks involved with nuclear power, but thanks to innovations like those you've seen today, the industry is doing its part to balance potential threats and benefits. So, we'll see you next time, and until then, enjoy the ride.